So where this becomes apparent is when we start adding and subtracting. That's where really significant digits become important, because when we're mixing chemicals and doing stoichiometry and all that stuff, that's when we're adding, subtracting, multiplying, dividing. That's when significant figures really come into play. So when we add and subtract numbers, we're going to round to the least accurate place value. So the number with the least accurate place value, that's what we'll round to. So with addition and subtraction, we round to the lowest number of significant figures. So there's only one significant figure after the decimal point. That's what we're going to round to. So that means it's going to be here. So the answer will be 5.9. So we're only going to have one significant figure after the decimal point, so we're going to round up in this case. So we have 3.688. There's two significant digits after the decimal point, so that means there's only going to be two significant digits here. So we're going to round to 3.7. Okay, let's try this one. We have 3.9405 minus 2.71. So that comes out to be 1.2305. There are two significant digits here, so that means our answer is going to have two significant digits. And this is a 0, so we just keep it at 1.23. So the reason we use the smallest significant digit is because if we add a value that is much smaller than the last digit of another value, it becomes irrelevant. For example, from my high school, where I graduated high school, Crawford High School in San Diego, all the way up to this high school here, that's 2,340 miles to my room of 236. Now, if I add from my room to 236 to room 240, that's a matter of feet. So that it really becomes irrelevant. It's basically the same distance. The 20 feet to room 240 from my room is really just irrelevant. So we really don't need to even deal with that. This is the rule we were looking at. When adding or subtracting, the number of significant digits is determined by the significant digit furthest to the left when numbers are aligned according to their decimal. So example, we'll do two examples here. We have 13.64 plus 0.0075. We align the decimals, and we're also going to add 67, and that becomes 80.715. Now this number 67 does not have any numbers to the right of the decimal, so there's only going to be these two significant digits. So that means we're going to have to round this one. And we get 81. That's going to be our final answer. The next problem, 267.8 minus 9.36, is going to be 258.44, but as we see, the 8 is the fewest one, so that means we're going to have one significant digit after the decimal place, and we're going to round down, and we're going to get 258.4. So we don't need anything else. That's as specific, that's as significant and precise as we can get. So some other ones, let's try this. Try this at home, and let's see what we get. So stop the tape, stop the video, try it at home, and we'll look at what our answers are. Our answers, you should have had 83.14 for the first one, and you should have had 4.02. So this is an interesting case. Even though we added 0.001, it's still the same, because that's as specific as we can get. That's as significant as we could get. we're adding such a small amount here, it really doesn't matter. It's just like when we added 20 feet from traveling from my high school to our high school to Ash. It really is still 2,340 miles. We're not going to say 2,340 miles and 20 feet. It's insignificant. And this number, 0.2983 plus 1.52, you should have got this. These two decimal places didn't matter, as well as these two decimal places. So we're just looking at the fewest decimal places. With multiplication division, we're going to round to the lowest number of significant figures. What we're going to do, we're going to take the number with the smallest number of significant figures, and that's what our answer will be. It'll have one significant figure. So for instance, well, this actually comes out to be 70 anyway. So that's the number of significant digits we have. Let's make this a little more challenging. So if we multiply 240 times 3, we only have one significant digit here, and we have two significant digits here, but we only care about the lowest one because we always remember, we're always concerned about the number with the least number of significant figures. So this becomes 720. But it only has one significant figure, so we have to round. We're going to round down, so this number is going to be 700. Let's try another one, 25. And we'll multiply that by... Now, here's the thing. It doesn't matter if we have 3 million... Now, I just... bunch of significant digits here. It doesn't matter. Let me do this quickly in my head. That is 759, 75525. And we only have two significant digits here. So our answer is going to be in two significant digits. So we're just going to round. That's going to be 7. We're going to round to this one. 76,000,000. So again, determining significant digits for questions with multiplication division is slightly different. You have the same number of significant digits as the value with the fewest number of sig digits as one of the products. Okay, so let's again look at some more examples. Let's look at the first one. 3.45 has 3 sig digits, so the answer will as well. If we multiply that out, it has 3 sig figs here, but so we're going to go up to this number. So that's going to be 2.10. That's 3 sig figs, and we wrote this in scientific notation, which we really should get in the habit of doing. So 3 sig figs there. 4.8 has 2 significant digits, so the answer will as well. If we divide by 392, we get this huge number, but we only want 2 significant digits, so we're going to round to this. 2 sig figs here. And we put it in scientific notation, 1.2 times 10 to the minus 2. Here's a bunch of problems we can try. So pause the tape, run through these, try them, and we'll be back in a second, in a jiffy, to check your answers. Okay, so hopefully you're back now, and let's check how you did. Okay, so we should start off with this as the answer. This one had 4 significant digits, so we should have 4 significant digits here. 1, 2, 3, 4. Here we have only 1 significant digit, so if we multiplied it out, we only have the 1 significant digit there. Here we have just 2 significant digits. We multiply it out, we have 2 significant digits there. Here we had 6.12 times 3.734. So we do this one first. That's 22.9 plus 7. So we have 22.9 equals 29.9. Okay, so for this one we have 2 significant digits here, but we only have 1 significant digit here. When we added them up, it was a 0.0230, but we only want 1 significant figure, and we round, and we just get this. So, interestingly enough, it's the exact same answer. So adding this wasn't significant enough to make any difference. If you're benching 250 pounds down there in the gym and then your friend puts a feather on top of it, it's really insignificant. You still really bench 250 pounds. You don't go around telling and bragging to everybody in the student lounge that you bench 250 plus a feather plus half a gram. You're not going to do that at all. You just say 250. That's basically what you do. So something as insignificant as this won't make a dent when we come to significant figures. So here are some websites that you should try just for practice, just so you can really get it down. Also, you can Google significant digits, and those will come up as well.